Math 3 students, we're going to continue with solving logarithmic equations today. We'll go ahead and we'll just get started here with number 11. All right, so in this case, our log is already by itself. Now, sometimes in the other problems, right, we have to work to get a singular log on one side. In this case, we've already got that, so what we can go ahead and do is just write it as an exponential. Now, something that is incredibly important is when you write this, because the base has more than one term, or even just, I guess, more than one thing, we're going to take it and raise it to the second power, but we got to make sure that we put parentheses around it. If you don't do that, it's going to be wrong. All right, so all I did was rearrange it. Again, that's just me rearranging from log base B, C equals A. You go B to the A equals C. This is incredibly important. You got to make sure you got that down. All right, so then we go ahead. We're going to go FOIL this out. Do not distribute the 2. This is not equal to x squared plus 16. Do not do that. Remember, you cannot distribute if you have a plus or a minus. You have multiple terms in there. What we have to do is go ahead and write it out twice and multiply. So x plus 4, x plus 4. We get x squared plus 4x plus 4x plus 16. We get x squared plus 8x plus 16. All right, so at this point, we've simplified the left-hand side. We can clearly see we've got a quadratic here, so what I recommend doing is getting everything on the same side and attempting to factor here. So we'll go ahead, minus x squared, minus 8x, minus 8x, and minus 16. Now, again, I want to make sure that I keep this guy with the highest power positive. So I'm moving everything to the right-hand side so that that first term will stay positive for me. So we get 0 equals 2x squared minus 10x. And then these actually cancel. So this is what we're left with. All right, so now we can go ahead and factor this. Now, when you've got 2 terms like this, you're either going to have like some difference of cubes, difference of squares, or GCF. In this case, it's just a GCF. And we can go ahead and set these equal to 0. We get x equals 0 as a solution, and x equals 5 as a solution, and we got to go check those. So again, we can go ahead and plug these in here. When I plug a 0 in, I get a 16, which is good. And then let's see, when I plug a 5 in, 3 times 5 squared, oops, that's to the 5th, minus 2 times 5 plus 16. I get 81, so that one's good. All right, so that is how we can go about something like that. Next one, similar kind of problem. Again, we've got the log isolated, so we can go ahead and just straight away put it in a exponential form. Now, you still want to put this in parentheses because you got to raise both the 2 and the x. If you put 2x squared, that's wrong. You got to put the 2x in parentheses so that we end up with a 4x squared. Again, we've got a quadratic, so let's get everything on the same side. In this case, I'm going to move everything over here because I want to keep that leading coefficient positive. So we do minus 9x plus 18 plus 18. So then we end up with 0 over here, and we get x squared minus 9x plus 18. This is a nice and easy one to factor. What multiplies to this and adds to this? It's going to be x minus 3 and x minus 6, sorry. We set those equal to 0, and we get 3 and 6 as our possible solutions. Of course, we need to go plug those in and make sure that they give us positive values. So let's see, that's going to be 3 times 3 squared plus 9 times 3 minus 18. So that one's good to go, and then we got to go test these 6 in there to make sure we're good. And we are good to go there. All right. So let's see, we'll go ahead, we can do one more of these. So in this case, it is only just one term. You could put parentheses and do like x squared, but this one doesn't need it because it's literally just like one thing being raised to the power. So we get x squared equals 7x minus 12. That's me writing it as an exponent. Again, we've got a quadratic, get everything on the same side, keep that leading coefficient positive. So I get x squared minus 7x plus 12 equals 0. We got to factor this. What multiplies to 12 adds to negative 7. That's going to be x minus 3, x minus 4. And our solutions here we get as 3 and 4, and we got to check them. If I put a 3 in there, I get, what, 21 minus 12, so my 3 works out. Put a 4 in there, I get 28 minus 12, also gives me a positive value in there. Now, these next ones, natural log. So just like we know, like if we have log of x, that's like saying log base 10 of x, right? But we just don't write that 10. Now, when you see ln, okay, ln is the same as log base e of x. I'd write that down. Probably like, what the heck is e? Well, e is an irrational number. It's very similar to pi. And it comes up a lot in just math. So just, if you go to your calculator and do what, second ln, that gives you e. So e is 2.71828188285. It just keeps going on forever. It's similar to pi, right? Like if I were to plug pi into my calculator here, it just gives me this really long irrational number. You don't really even need to know what value e is equal to. You just need to know that ln is the same as if we had log base e. Okay? So let's go ahead and try and solve this. First, let's work on getting our log by itself. We're going to subtract 10. So we've got 2 ln 2x plus 4 equals negative 6. We're going to divide by 2. And I get that ln of 2x plus 4 equals negative 3. Now at this point, our log, or our natural log here, that's what it's called, is natural log. I guess I probably should have wrote that natural log. Oops. At this point, the log's by itself, so we can write it as an exponent. So we could just say e to the power of negative 3 equals 2x plus 4. Now, we don't want to plug that into our calculator because that's kind of like gross, and they want exact answers. So basically what you do is you just treat e like a variable, okay? At this point, all we need to do is just work to get x by itself. So to get x by itself, we need to subtract 4 from both sides. So we get e to the negative 3 minus 4 equals 2x. We divide by 2. It's kind of just like solving literal equations like we've done before. So we get that x is equal to e to the negative 3 minus 4 all over 2. And this would be your answer because they asked for a exact answer, and that's how you're going to give that. All right, let's try another one. So again, we want to isolate our log. So we'll go ahead. Let's add 12 to both sides. We get 4 ln of 3x plus 5. equals 28. We're going to divide by 4. ln of 3x plus 5. Now at this point, our log is by itself. We can write it as an exponent. We get e to the 7th equals 3x plus 5. Get our x by itself. So we end up with x is equal to e to the 7th minus 5 all over 3. All right. So that's how you're going to solve ones like those. Hopefully it's not too tricky. It feels a little weird, right? Because you're not giving an actual just like number as your answer, but it's not too bad. So then let's go ahead. Now that we know what ln is, let's just talk about evaluating some ln's. Again, remember that ln of x is equal to log base e of x. But we never write it like that, but that's what that means. So here we know we can take this 5 out in front, okay? So it's like 5 ln of e. Well, if we're trying to evaluate ln of e, okay, that's like saying log base e of e, what is that equal to, right? Well, e to the power of what gives me e? It's 1, right? It's the same thing if I said like log base 7 of 7. The answer there is 1. So ln of e is equal to 1. So we can just replace that with a 1. It's like 5 times 1 gives me 5. All right. Another way you could think of it is just like if we have ln of e to the 5th, that's asking e to the power of what gives me e to the 5th. Again, that's 5. That's kind of two different ways to think about that. All right, next one here. This one, couple of different ways you can think about it, right? If we have ln, so if it 1 over e squared, think about that as e to the negative 2. So e to the power of what gives me e to the negative 2? It's just negative 2. And the last one here, ln of e to the 1/5. Remember, always think of radicals as powers. E to the power of what gives me e to the power of 1/5? It's 1/5. That is it.